Hi there, in today's session we're going to look at descriptive analysis within SPSS. Specifically, we're going to look at the frequencies and explore function within the program. In terms of testing frequencies, we're going to be looking at categorical variables, i.e. nominal or ordinal, and testing for the following things. When we've entered data into the dataset, have we made mistakes and therefore created out of range values that we need to rectify? What are the counts, i.e. the number of people in each category, for our categorical variables? And how do these translate into proportions as percentages? And we can make assertions about the size of the sample population as a result of these proportions. Something like 10% are aged 18 to 25, etc., etc. We're also able to use the explore function. In this aspect, we're going to be looking at explore for continuous variables, i.e. interval and ratio level data. Similarly, we'll be looking at out of range values, and we'll be taking that to look at mean scores, standard deviations. We'll look at minimum and maximum as a result of that, and a wide range of descriptive statistics. And we'll also learn how to bring up the tests of normality within SPSS. Okay, so the first example comes from the OCGS, Older Grocery Customer Satisfaction, or Older Customer Grocery Satisfaction dataset. And the question that's been posed is, what proportion of people in our dataset consider themselves to be of mixed ethnicity? So people have been asked to self-complete what ethnicity group they fall into. What we need to consider for this is the data categorical, as we need it for frequencies? Now there are situations where we can do use frequencies for interval and ratio level data, but it's most common when we're looking at a categorical variable. In this instance, yes, we know that actually the variable is nominal, which is fantastic, but we do also have to test to make sure that we don't have any out of range values. Okay, so within the SPSS file, the variable that we're interested in today is question 19, what is your ethnicity? Now, if we click on the values button, we can see that there's 6 options available for people to self-report their ethnicity: white, black, Chinese, Asian, mixed, and other. Our objective is to identify what proportion of people said that they were of mixed ethnicity. The way we do this is through the analyze and descriptive statistics bar in SPSS. Because we have categorical variable, a categorical variable, we need to use the frequencies command as opposed to the descriptives or explore command. As you can see, ethnicity is already in the box here, but if it wasn't, we can simply copy it across like that. Now the key here is to make sure that we have the right settings that we would ideally want for our analysis. So in the first instance, we're quite interested in finding out whether we've got the right inputting of our data, that we haven't got any out of range values. So in the first instance, I'm just going to say minimum and maximum, and we can come back and we can do a little bit more to this in a minute. But in the first instance, let's just have a quick check. Okay, so SPSS chucks up this window and it tells us that there's 228 valid and 4 missing. So in the system, there's 4 that have stated or have been inputted as -999, saying they're actually missing. We've got these values here for white, black, Asian, mixed, and we have this strange value here of 100, a frequency of 1, representing 0.4 in our dataset. Well, because there is no code for 100, i.e. we had, remember, 1 to 6, that to me says, you seem to have a error of some kind. Okay, we need to find that error within the data set and make the change. So it's going to be held somewhere here. Now we know that we can find it by highlighting question 19, pressing Control F and searching for the value that we found, which is 100. Here it is here. Now, what we would do in this situation is go back to our original questionnaire, which is a good reason why we should label them, as we put them into the SPSS. We know it was in case 183. I know that actually this is a mistake and that this person was actually white, which is a value of 1. So we can change that back to 1. We save our data set to reflect our change, and we can continue with our analysis. Now we might want to use a little bit of some extra features within SPSS. Now, in general, this is absolutely fine. We don't need to worry about that. But we might want to add in a bar chart just to show how this works. Now we have the frequencies. It is quite useful to use percentages. So I'll click OK, and SPSS will give me the new data with no out of range value with the 100. And this is what our data looks like, and as you can see, it's incredibly skewed towards people of white ethnicity. Very few blacks, Asian, or people of mixed ethnicity are represented in this particular data set. The second set of descriptive statistics we want to look at today is using the explore function. Now, the explore function is useful for continuous variables, either interval or ratio. So we might have age, or we might have some Likert scale. And this differs from categorical variables because we're able to assess a mean score, and with that mean is attached a standard deviation and a variance. Okay, and it's quite useful in multivariate analysis. So within our data set, we've been posed the question of what is the mean age of people in the sample. So we want to find out what the mean age is. Remember, this is an older customer grocery satisfaction data set, so that they're all people over 60 years old. Okay, but we want to find out what the mean age of people is within this data. Now we do actually have a few considerations that we have to think about. Is our data continuous? Well, actually, yeah, we know it is, that's fine. Are there any out of range values? Well, we're not sure, we're going to have to check for that. And do we have normal data? Now this is really important, and it's something we have to check by using a histogram. Okay, and actually within the explore function, we're able to do this as a basic command. Okay, so the variable we're interested in is question 8, age. Okay, and we know that this is a continuous variable. Okay, as a first port of call, let's just check to see that we've got the right number of, there's no out of range values within our data set. Now we can do that in Explore. And we'll set up the entire test as well. So we have to move the age variable into the dependent list. Notice here at the bottom we can run both statistical tests and graphical plots. Now we'll have both of this because I think it's quite useful. Click on statistics. We'll have a look at some outliers. Here's very important, we'll have a histogram. We'll get rid of the stem and leaf, and we'll make sure that our normality line is also plugged with the test there. Now, we're only interested in really looking at case of data that are in the data, so we'll just leave that option as cases list-wise, and we don't need to bootstrap. Okay. SPSS will throw up this this value here. Now, as a first starting point, what we want to look at is whether or not we have any what we consider out of range values. So I'm going to automatically skip down to the extreme values table here. Now this tells us the 5 lowest cases and the 5 highest cases in terms of their mean age, or their actual age. Okay, so if we look at the age of the highest age of the person in the data set, we can see it's person number 1, and that is person 67 in the data set, and they are aged 93. Okay, that to me doesn't seem like it's out of range considering the age group that we're interested in. And actually the lowest score is 60. Well, this is what we need them to be over 60 years old, so there's no missing data in this particular test. We're also interested in our normality. Normality is something that's really, really important. We'd expect that our Kolmogorov, Smirnov and Shapiro-Wilk tests for normality should be significant. And actually what we've got here suggests that we're okay. Our histogram is obviously going to be front-ended towards 60 years old, but we've also got a fairly decent curve there as well. Now if I click there, double click on there, it gives me this chart editor view, and I can just add a normality line there, and that tells me quite a bit about, yeah, okay, I think we're just about at a normal level. We can compare that by looking at the observed and expected plots, and you can see that it's actually only really at the lowest and at the kind of highest end as you get really older that we get not our expected values deviate from our observed values. So in the middle, so between 70 and 80, what we observe and what we expect is pretty much spot on. And we'd expect this line to be exactly like this. We expect it to be kind of like a flowing S shape. Okay, so normality is great. We can say, yeah, I think we've got what we want. We want to move on from there. Let's have a look at the more descriptive statistics. First of all, we can see that the mean age of people in the sample is 71 years old. Well, that does correspond to our histogram here. Those people there are around 71. Our median is also 71. Now, you may recur that when our mean, our median, our mode all equal the same, that's a good indication of where we have normality. So that's a good sign. Variance is 60.959, and when we take that by itself, it doesn't really mean anything. However, when we take it in context with our standard deviation, because variance is standard deviation squared, this actually means something quite important. What we're essentially saying is that the average difference from the mean is about 7.8 years. Okay, so one standard deviation from the mean is 7.8. 2 standard deviations from the mean is about 15 years or so either side. Okay, but we say around 95% of the sample fall within those categories, those 2 standard deviations from the mean. Our minimum level is 60 and our maximum level is 93. It's a range of 33 years. And just something else that we need to consider in terms of normality is skewness and kurtosis. We're actually quite lucky in this situation because they're between -1 and 1. When they're over -1 and 1, that's where we have something to be concerned about, and we might have to do some further diagnostics to see whether normality is a problem or not. But within this circumstance, actually, our data is fine.